As a former science teacher, I learned that it's really important for students to be able to read and write in the language of science.
With college professors and people that I talk to, I often hear back that students can't write. They say students can't write, students can't look at data when they get to college.
Reading and research comes into play across the entire gamut of what we do. Most engineers like to go into engineering because of the science and the math. We're good at this type of things, but writing and reading is a huge part of what we do, and they don't really focus on that as much in school.
We needed to find out how literacy is being used in the real world by scientists and engineers, and determine how to best integrate that into the classroom.
My name is Claire Hampel. I'm a middle school teacher here at the Metro School, and I teach science and English.
So we're going to get started today with a little something different, and this is a little activity that's going to get us started on our next project, and our project is going to be called Squirmy Science.
The module that I'm doing is actually the design module, so actually creating something that the students decide how it's going to be built.
The ability to write with exactness is essential to the ability to think scientifically. What the Ldc Science Modules accomplish is they scaffold the process for both teachers and students to be successful reading and writing in the language of science.
I'm a design engineer at Patel, and so what happens is we usually get an RFP from the client, which is a request for proposal, and they say, here's a document that describes something that they want.
We're going to actually take a look at the full project, and this is actually called an RFP. And the RFP is a request for proposal, and this is kind of what a customer would come to you with in wanting to create something. So we're going to actually create a habitat for our new friends, the mealworms.
So you have to kind of interpret all these parameters and all these requirements that they want, and then give them a proposal. Proposal is like a concept as well as costing and schedule to develop that gadget or widget that they want.
So not only are they teaching the students how to write about what they've done, they're teaching it in a scaffolded context. And that's much more effective than saying, here, do a lab report, here, do a research paper, here, do a scientific paper. They're saying, this is what we're going to do, this is why it matters, here's how we're going to communicate that to everybody.
The challenge is really to create an inexpensive, cool-looking educational toy for teachers and mostly kids to play with. And something that will actually keep the mealworms alive.
After the students individually did research, they worked together as a team to create a research summary of their findings. And I had them basically divide and conquer that into 3 paragraphs that I had previously told them the questions for that they were to answer in those sections. And then they took that information as a team and they designed what they were going to build for their mealworm based on what they thought the mealworm would need.
I found out that mealworms eat apples. The apples count as water and food. So we could just use the apple as food and water instead of having to pay for water and the food.
I think one of the arts of design is being able to separate the creative process from the critical process. Both are necessary, but sometimes it's helpful to be creative first and then critical second. Claire gave her students that exact opportunity in asking them to brainstorm all the possible solutions they think they could come up with. But now, next, they're going to go through a rigorous and critical process as a team to parse out the different components of their possible solutions to decide which would actually address the need the best.
Oatmeal and 1-inch square of apples.
Okay.
I think that should be enough to...
How many mealworms?
I was thinking 2.
2?
I'm not exactly sure what would be a good amount, but the more mealworms we have, the more food we have to have prepared to feed them.
Learning to balance cost, schedule, and actually solving the problem. Any engineer would love to have an infinite amount of resources and time to be able to solve a problem, but there's always a constraint on schedule and cost. And learning to balance those is really what makes engineers engineer. Maybe not the 100% best solution, but a solution that meets all the requirements is always the best.
narrowing down these great ideas, these creative ideas, and bringing it down to a realistic place where the kids can all agree as a group what the best design is. And so I actually have a design matrix, and the decision matrix, again, they're gonna list their top ideas and then evaluate them based on the criteria that is in the rubric. So they're gonna write up a formal proposal, they're gonna draw their design, and then they're gonna actually build it.
The essence of STEM education is production, and the fact is all students actually want to make something valuable. And so I was just so excited to see today that Claire's design module had the students asking, could we sell the things that we're making for profit?
Students are so intrigued to know what the mealworms are doing each day that they come running in and they look for their mealworms, they make sure that they're alive, they want to see what they're doing, and they're watching them so intently that I have to tell them that we have to write down what we're seeing. And to me, that's really authentic data collection. And I think a lot of times in science, we're asking students to collect data for some artificial lab. And it's just so nice to have the opportunity to actually create data that means something to them and that is really scientific observations and inferencing.
Okay, for your data today, I'm just gonna take a sample of somebody from around the room's data. I'm gonna write their data up. But obviously you're gonna write down whatever you're seeing. So can I hear from a group, how are your mealworms moving today? What are you noticing about their movement?
So the students were working in teams of 3, so I decided to combine 3 mini tasks together. The first task that we did was the title page. The second mini task that another person in the group was doing was selecting the final design drawing.
We have to draw our project, but we have to label it very specifically, how many milliliters of dirt we have or oatmeal. So I had to draw it, then label it, and we also had to make sure our mealworms are alive. So if one was dead, we'd have to label that too.
And then finally was to describe that final design into a little paragraph.
We're going to be writing what materials we used to create the bottle, how we created the bottle, and how much of the materials we used.
The importance of writing a description of their final design kind of comes with a metacognitive ability to reflect on your design and see how successful it was at the end. So maybe that someone else could create it. Maybe something that you didn't do so well, what aspect of that would have you redesigned in the future?
Creating a design report is a very critical skill for kids to develop. It's because one, it's fun to actually build it and design it, but then learning to actually take that information and communicate that to other people so down the road they can kind of learn from that, so if they want to make further advancements, they can.
My final step in the process was really taking a look at what the students did and sharing that with the Battelle scientists and seeing what their expectations were and if the students met those. And if they didn't, what could we do differently to teach it in a different way or modify what we have to make it even better?
They described pretty detailed how much water they used, how much they weighed before and after, the size bottle and container they went in there, and the type of foods they used. I mean, I think the description of what they did was pretty good.
When we came back to the end of it, he was very impressed with the work that the students had created. We all are digging deep. We all work really hard in planning authentic experiences for our students. And this shift to design module really just takes it to the next level of just being a little bit more intentional with the way that we're planning things to help our kids think more critically. So not just designing once and turning in that science fair project, but actually going back and evaluating within the task still before it's finally due. And that small change can make a huge impact on your students' learning.